Hello all, welcome back to my YouTube channel all about VLSI. In this particular video, we are going to try to understand about PCIe configuration registers. In our previous video, we have tried to understand about configuration space and we have also tried to understand about enumeration and all. Now, in this particular video, we are going to try about understand about PCIe configuration registers, like what exactly the configuration space is going to have, what are the different kind of registers we are going to have and all. So first of all, what is a configuration space and why it is going to exist, that we have already discussed in our previous session. Let me once revisit one more time. So every PCIe function, it is going to have a unique device ID, bridge, and root code, and it is going to carry a dedicated block of registers, which is known as configuration space. So every particular PCIe function is going to have this kind of configuration space that we have already seen, and this is basically separate from memory space and input output space. Also, we have seen, and system is going to identify you. It is going to discover and what hardware exists and identify it and program how it participates on the bus and all before going to touch any particular memory or input output space. And unlike our memory or input output space, software cannot choose whether to use configuration space. It is mandatory that every function should implement this particular configuration space. It's not an optional feature. The configuration space should be present within every particular function, and each function is uniquely addressed by a particular property which is known as BDF, which is nothing but bus number, device ID, and function number. So also known as its requester ID. So basically, this particular configuration space is going to be 4096 bytes per function, and in legacy conventional PCIs, it is basically 256 bytes. And PCIe also added 3840 bytes of extended configuration space also. Okay, and how are we going to identify this particular configuration space? Using bus, device, and function. And this particular bus is of 8 bits, and this device is of 5 bits and function is of 3 bits. That means each particular device can have 8 functions, and we can have 32 devices and 256 buses which are present in this particular PCIe. Now, how your configuration space is going to look like? So in the configuration space, I'm going to have first particular field which is known as header. This is the first field which we are going to have, which is nothing but my header. Next is capability list, and this is basically PCI compatible. So it is basically giving backward compatibility to PCI devices. So this is capability list, and this is PCI compatible. And next particular field is PCIe extended capabilities. So this is a last field which we are going to have. So the first field which we are going to have is header, and next is capability list, and followed by PCIe extended capabilities. So what is this header? Header is basically, it's a fixed layout, and every function is going to have this header for sure. And capability list, it's an optional, and the PCIe extended capabilities, all those optionals. But in a configuration space, if a function is going to have a configuration space, obviously function should have a configuration space. It is going to have a header as a starting field. Now, basically this header is going to have a fixed layout field, and every function is going to have this particular header, which is going to basically have vendor ID or device ID, basically for identification, and command and status registers, class info, and base address registers. Regarding this particular base address registers and how my operating system is going to access this base address registers, and what is the different roles of this base address register and all, we have discussed in our previous sessions in great detail. If you haven't watched it, I recommend you to once go through those particular sessions. And header is going to have all this particular fields: identification register, command and status register, and class info, and base address registers. And coming to next particular field, which is capability list, which is PCA compatible, and it's completely optional, and it is self-describing linked list of features block, like what are all the features, PCA related, PCA compatible features it is going to have, like power management, MSIX, PCI Express capability, and etc. All the features will be present inside this particular register fields. And next is extended capabilities, and it is PCIe specific linked list, and it is used for advanced error reporting, virtual channel, SRIOV, and all. So this is nothing but my extended capabilities. So in a particular 4096 byte of a uh, configuration space which is related to a function, this is what we are going to have. The first particular portion of registers are known as headers, and next portion of registers are basically capability list, which are basically optional, and the third is PCIe extended capabilities. Now, headers also, we have two kind of headers. If I'm going to use an endpoint, I'm going to use a type 0 header. And if I'm going to use a bridge, which is nothing but we are not going to have a physical bridge in our PCIe, we are going to have virtual bridges. And in virtual bridges, I'm going to use something known as type 1 headers. Like if you are having a switch, or if you are going to have a root port, you're going to have something known as type 1 headers. So the header type, we are going to have it in offset E. I will show you in the diagram, one second. So yeah, this is my type 0 header. These are the register fields which I'm going to have in my type 0 header. So first one is vendor ID, device ID, which is present in this particular address. And you can see at this particular offset address E, I'm going to have the header type. This is going to decide what kind of header it is, whether it is type 0 header or whether it is type 1 header. So using this particular header type which is present at this particular offset address E is going to tell the software how to how to interpret the bytes from 10 to 3F. So you can see from 10 to 3F we are going to have over here. So from 10 to 3F, my particular header is going to tell me from 10 to 3 if it is going to tell me like how to interpret the register fields. Okay, so both the layouts share the first 16 bytes, that is from 00 to F. So from 00 to up to here we are going to have the same fields, whether it might be a type 0 header or whether it might be a type 1 header. And after this, the fields or the registers which we are going to have will be differentiated in the type 0 headers and in the type 1 headers. In the type 0 header we are going to have different register fields, and in type 1 header we are going to have different set of register fields. Now in the type 0 header, uh, it is basically used by the endpoints. So it is basically used by the end device functions like NIC or GPU or controllers or USB controllers, etc. And type 0 headers are going to have basically 6 base addresses from bar 0 to bar 5. You can see over here we have basically 6 base registers which are allocated for type 0 headers. And it is also going to include subsystem, vendor ID, device ID to identify the specific add-in card. So here you can see we have a particular subsystem vendor ID and subsystem ID for in the case of my type 0 header. And it is going to terminate the topology and has no further buses behind it, because it is the end of the topology and there is no further devices which are present after this particular endpoints. So there is no information which will be present like what is exactly after this particular endpoints. Whereas in the case of my type 1 headers, type 1 headers are used for the devices like bridges, root ports, and switch ports. And this particular type 1 header is used by PCI to PCI bridges or PCI root ports and switch upstream or downstream ports. And this particular type 1 headers are only going to have two bars, bar 0 and bar 1. As I've told you, this particular type 0 and type 1 headers are going to have the same set of registers up to this particular address, but after this address it is going to change. So this is my type 0 header format. Let me show you the type 1 header format. Yes, this is my type 1 header. You can see up to here header type everything will be same, and after this you can see my register information has changed. So I have only two registers, bar 0 and bar 1, and from next onwards I'm going to have the register fields like primary bus, secondary bus, subordinate bus, and latency, and IO bus, IO limit, and memory base, memory limit. So these are all the different kind of fields I'm going to have in a case of my type 1 header, and in the case of my type 0 header, these are the different fields which we are going to have. Now, so in the case, this is about my type 1 header, and it is also going to add bus number and base limit registers that are going to define what lies on the other side of the bridge. So it is also going to forward the transactions downstream towards the subordinate buses. So these are the different kind of headers which we are going to have. and we are basically going to classify them according to the devices which we are going to use. If we are going to use an endpoint, we are going to have a type 0 header, and if I'm going to use a switch or a kind of bridge, I'm going to use a type 1 header. Now, let's see the common header fields which we are going to have, which is basically present in both type 0 and type 1 headers. So the first very field, which is vendor ID, and it is present at this offset address, and which is of 16 bits width. And this vendor ID is used to identify what is the manufacturer, and it is going to it is basically assigned by the PCI SIG group for uniqueness. And this particular vendor ID, if it is returning all F, if my OS is reading it, then that means there is no particular device which is present at all. So this is nothing but my first field, which is vendor ID, which is present at the offset 0. And next, at the offset 2, I'm going to have something known as device ID. So this device ID is of also 16 bits. It is going to basically use it for identifying the specific product or the chip, and it is basically assigned by the vendor itself. And next is revision ID, like what kind of changes if you're going to do that particular ID, you're going to have it in the revision ID. And next one is programming interface. So it is present at the 9 offset number 9, and this is going to which is basically present over here. And this particular programming interface, it is basically register level programming interface when the class defines like ID and all. And next is subclass code and base class code. These are the different kind of register fields which we are going to have. And next we have something known as command registers, like IO space enable or memory space enable, bus master enable, parity error response, and different kind of command registers which we are going to have. So you can see over here. So these are all which are included in my command registers. And I have something known as status registers. So in this status registers, we are going to have different kind of fields like interrupt status, capability list, master, and so on. So these are the different kind of status registers which we are going to have. And another is class code. So basically class code is going to tell me what kind of device it is, whether if it is equal to 01, it is a mass storage controller, and if it is 02, it is a network controller, and if it is 03, it's a display controller. And depending upon the class code, I'm going to decide what kind of device I'm working with. Okay. And followed by yeah, so these are the different kind of fields which we are going to have. And it's not like you need to remember this everything, like exact meaning of each and every particular field. When you're working with this particular kind of header, you can basically refer to the specifications and learn. And the main motive of this particular session is to understand like what exactly which is present in the configuration space, and what are the different kind of fields which is present in the type 0 header and type 1 header. Okay. So these are the different fields which we are going to have in the type 0 header. And according to the requirement, when you're working with a different with a specific kind of project, you're going to refer to exact meaning of that particular field, and you're going to work with them accordingly. And next, I'm going to have type 0 specific fields. If I want to refer, I'm going to have type 0 specific fields like card bus or subsystem vendor ID, subsystem ID, or expansion ROM base address, capability pointers, interrupt lines, and interrupt. So these are all dedicated to only type 0 fields. And after this, I'm going to have type 1 header. As we have already seen, these are the different kind of fields which we are going to have in the case of my type 1 header, where type 1 header is used for only bridges or the root ports and all. And this particular type 1 specific headers, we are going to have this particular kind of addresses like primary, secondary, subordinate bus number, and IO base limit, and secondary status, and so on. So these are the different kind of type 1 specific fields which we are going to have. Okay. And in the capability list, we can have different capabilities like PCI power management or MSI message signal interrupts, and PCI Express capability structure, and all so on. So these are the different kind of registers which we are going to have in our uh, configuration space. And the very first one is header, and again header is basically divided into two categories. One is type 0 and type 1, and depending upon what kind of device you're going to use, you're going to use either type 0 header or type 1 header. And in type 0 header, you have in type 0 and type 1, we are going to have common registers which we are going to have, and specifically type 0 has their own set of registers, and the meaning you can refer it when you're working exactly with a endpoint like a PCI device. You can refer to the specification of that and you can work with it. And when you're working with a type 1 device, you can refer to the specific register meaning and exact working of it, and you can refer to it and you can accordingly configure it. So this is nothing but my configuration space in a particular function. Yes. So that's about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.